production and costs. This is the first exercise which we are doing. I will be working on my laptop and I will record this session and you will be able to download this video from Moodle. So the first exercise, here you are asked to calculate various types of costs, and we start with the simplest possible versions of costs: total, average, and marginal. So total costs is simply a combination of all costs which you incur in the production process. And the formula which we normally use is a sum of total fixed cost plus total variable cost. So all costs which we incur in the production process. These are total costs. Average costs are simply costs per unit of output. And to calculate this, we simply take total cost and divide by quantity, total cost and divide by quantity of output. For example, we've spent £100 to produce 10 units. It means that it cost us £10 per unit to make this particular product. And marginal cost is probably the most difficult type of costs. Marginal costs show you additional costs of producing one extra unit of output. Additional costs. It shows how total cost changes when we change output by 1 unit. Triangle stands for a change. It's the change. Marginal cost shows us how total cost go up if you produce 1 extra unit of output. Marginal cost, as you will see, is not the same as average cost. You don't incur the same additional expenditure when you increase output. It's not the same as average, which you used to spend overall throughout your whole production process. And this exercise will demonstrate this. Basically, the exercise is very simple, and I will explain you each and every step. So, first of all, when output is equal to 0, total cost is 55. What is the average cost per unit? Nothing. We cannot calculate it because it's not 0, it's nothing, because we cannot divide by 0. To calculate this number, we would have to divide total cost by output. 55 divided by 0 cannot be calculated. That's why we skip this one and proceed to the next step. When our output is equal to 1, total cost is equal to 85 pounds. Therefore, average cost per unit is 85 divided by 1, which is 85. Next, when we produce 2 units of output, total cost is equal to 110, which means that it costs us 110 divided by 2, 55 pounds per unit. Average cost per unit is 55. The same further down our column. When we produce 3 units of output, total cost is 130, which means that 1 unit costs us 130 divided by 3, which is going to be 43.3. Next, here we need to do the opposite situation. We don't know what is the total cost. However, we are given average cost per unit, and we can work in the opposite way. So here we produce 4 units of output. It costs us 40 pounds per unit, which means that the total cost will be 4 units times 40 pounds per each, which is 160 units. This is how we can fill in this particular spot, this particular question. Next one, similar question. When we produce 5 units of output, it costs us 42 pounds per each unit. So in total, our overall total expenditure will be 5 times 42, which is 210. 6 units of output, total cost is 280, which means that the average cost will be 280 divided by 6, which is equal to 46.7. 46.7. I'm not using a calculator at the moment, but you can always compare your answers with the correct answers provided. Okay, now we cannot proceed any further because for 7 and 8 units of output, we don't know any of these numbers. We don't have total or we don't have average costs. However, we are given marginal costs, so we will need to use this information in order to calculate the rest. How can we do this? Let's start from the very beginning and apply our formula. Marginal costs show us how total cost changes when quantity changes as well. I will change the color to make it slightly easier. So have a look. As we increase output from 0 to 1 units, our total costs go up from 55 to 85. In other words, change in total cost is equal to 85 minus 55, which is 30. Our total expenditure go up by 30 pounds when our output goes up by 1 unit. Change in output in our case will always be equal to unity. So our denominator here will always be equal to unity. In this particular example, it will be equal to 1 here. here in question 1. So that is why we always have to divide by 1, and this saves us one extra step in calculation. So when output goes up from 1 to 2, from 2 to 3, it's always one extra unit. So basically we can just eliminate denominator in this particular exercise and only have a look at numerator, change in total costs. So change in total cost between 0 and 1 unit is equal to 30. Total cost jump from 55 to 85. That is why marginal cost will be equal to 30, this difference. Next, as we increase output from 1 to 2 units, our total cost go up further from 85 to 110. So change in total cost will be equal to 110 minus 85, which is 25 pounds. So the marginal or additional cost of producing second unit of output will be equal to 25 pounds. Please pay attention, it has nothing to do with average cost. Average cost used to be 55, but marginal cost is 25 pounds only. Next, when we produce the third unit of output, our production level goes up by one more unit. Total cost increases again, but by a different amount, from 110 to 130. So marginal cost will be equal to 130 minus 110, which is 20. 20 is the correct answer. And so on. Movement from 3 to 4 increases our expenditure from 130 to 160. The difference is equal to 30 pounds. That's our marginal cost. Next, movement from 4 to 5 units increases our total cost from 160 to 210. The difference is equal to 50, and this is our marginal cost for this production level. And that's it. And we cannot proceed any further because we don't have any more data. So what we have here, we need to calculate. Do we have? No, we have this extra data point from movement from 210 to 280. So we can complete this particular one. Difference is 70, and then that's it, and we stop here. Now we'll need to work backwards. We'll need to use marginal cost data, these numbers 90 and 110, to work out total cost and average cost. So have a look how we do this. As we move from 6 to 7 units of output, our total cost should increase by that amount. So total cost go up from 280 to some number which is 90 pounds higher, which is going to be 370. So because we know that marginal cost for this 7th unit of output is equal to 90, it implies that as we start producing this 7th unit of output, our total cost will go up by 70 pounds from 280 to 370. And similarly, when total production goes up from 7 to 8 units, our total cost will go up by 110. And we use this information. So 370 previous total cost will increase by 110, which means that the new cost level will be equal to 480. And the final bit here, absolutely the same thing. We used to spend 610. Now we'll need to add 150. 610 plus 150 is going to be 760 pounds. So we've completed all information, all data for total cost of production for this particular production process for this company. Now let's fill in the rest of the table. Now we can proceed using our previous case. Let me keep blue here because we are following the standard procedure. If it cost us 370 to produce 7 units, it means that each unit will cost us 370 divided by 7, which is 370, 52.9. 52.9. Next, 480 pounds spent to produce 8 units. 480 to produce 8 units implies that we are spending 60 pounds per unit. Next, 610 spent to produce 9 units, which is going to be 610 divided by 9, 67.8 per unit, per each unit. And final bit, 760, spent to produce 10 units of output. This is going to be 76 pounds per each unit. And again, the only piece of information which is missing is this particular point, which shows us how our total cost will increase if we increase production level from 8 to 9 units. In other words, our cost will jump from 480 to 610. The change will be equal to this difference between 480 original amount and 610, the new amount, which is 130. So this completes our table. So this is how we calculate this. So I've shown you all the formulas, the whole process, not just answers, but the whole process. And you will be able to come back to this recording if you need to check to recall how it's been done. What is interesting here, what you can notice here, have a look how total cost change as we increase output. Output goes up from 0 to 10 units. Have a look how total cost will increase. Total cost start at 55 and then they go up. So it's an upward sloping line. Total cost go up. And what is interesting is that they don't start at 0, they start at 55 pounds. Even if we don't produce anything at all, even when output is 0, total cost is equal to 55 pounds. And it could be a straight line, it could be some curve, we don't know what is the shape of the curve, but what we know is that it is an upward sloping line. Costs always increase, 55, 85, 110, 130, 160, and so on, all the way up to 760. It's an upward sloping line. Total cost always go up as we produce more output. Average cost has more complex shape, and as you can notice here, it will look like a letter U. It's a U-shaped curve. Have a look. We start with a high number, 85, then it drops, 55, 43, 40, then it starts to go up again. So 40 is the minimum in this case, drops up to 40, then starts to go up. 47, 52, 60, 67, 76. So this is our minimum of average cost. Our curve will look like this. It has a U shape. Average cost. Marginal cost. Start at 30, go down, 25, 20, reaches minimum. This is minimum. Then goes up again. 30, 50, 70, 90, 110, 130, 150. What is interesting here, it's also a U shape. It also has a U shape. But majority of the curve is upward sloping. So strictly speaking, marginal cost line will look like that. It's an upward sloping part for majority of levels of output. It will have a downward sloping segment, but most of it will be upward sloping. And what you will study later is that marginal cost, strictly speaking, represents the supply curve for the company. Slightly more advanced material. I hope we will be able to cover this. There will be not many questions on this in the exam. It's slightly more advanced. But strictly speaking, a part of the marginal cost line represents supply curve for the company. We'll come back to this later. So these are our monetary values along vertical axis, and these are our quantities. So this particular example, this exercise, helps you to memorize the formulas and also illustrates the shapes of some of the cost curves. So now we need to answer a few questions. There were a few questions here based on this particular topic. And the first question was, how much is total fixed cost for different levels of output, when output is 0 and when output is 6? Any ideas? Does anyone have any ideas about how much it would be, total fixed cost, when output is 0? Very simple. Let's have a look at our table. When output is 0, total cost is equal to 55. In other words, we don't produce any output yet, but we incur certain expenditure already. And this expenditure will represent fixed cost of production, which do not depend on the level of output. By definition, fixed costs are the costs which are not related to the level of output. You have to pay them regardless of how many units you produce. Whether you produce 1 unit or 10 units or 10 million units or 0 units, you will need to pay these costs. For example, rent. If you rent certain premises to run your production process, to run your business, you will need to pay to your landlord regardless of how many customers you serve, how many days you are open, how successful you are, what profit you make, how many items you produce. You will still have to pay your rent to your landlord. Or you need to pay the interest on any business loan to your bank, again, regardless of how many units of output you will manage to produce. It's a fixed cost. So that's why it's called fixed. It remains unchanged regardless of level of output. And in our scenario, when output is 0, total cost is 55. There are no costs of materials. There are no costs of labor. You don't pay any staff. No one is working yet. You don't produce anything yet. You only incur fixed expenditure at this stage. And therefore, this number represents total fixed cost. Total fixed cost. So the answer to question A will be total fixed cost when output is equal to 0 is 55. What will be the total fixed cost when output is 6? The same number. Total fixed cost when output is 6 is also 55. It's fixed. It's the same by definition. If you sketch a graph, it will look like this. Total fixed cost is equal to 55 pounds, regardless of costs along vertical axis, anything measured in money. Regardless of how many units you produce, 0 units or 6 units or 10 units or 10 million units, your fixed cost will remain at 55. Next question. How much is average fixed cost if output is 5 and if output is 10? So this was actually question B. Question, let me write it here. Question C. How much is average fixed cost when output is 5? And how much is average fixed cost when output is 10? This is what we need to calculate. How do we calculate averages? How do we calculate average values? Average, any average number, is number per unit. To calculate any average number, we take total and divide by quantity, by number of units. We spread the total amount across certain number of units. So here we need to calculate average fixed cost. So we take total fixed cost, the relevant figure, and spread it across certain number of units. And here as well, when we calculate for average fixed cost for quantity equal to 10, we do absolutely the same thing. We take total fixed cost and distribute this across relevant number of units, divide by quantity. So what is total fixed cost? It's 55. What is number of units? Quantity. It's 5, which means that average fixed cost is going to be 11 pounds. What is average fixed cost when quantity is 10? Following the same approach, we take total fixed cost, which is still 55. It remains unchanged, but quantity is now different. Quantity is 10, therefore total fixed cost is lower. The more you produce, the cheaper it becomes per unit in terms of average fixed cost of production. And that is why average fixed cost line, average fixed cost curve, looks like that. It's always downward sloping. It's always going down. The more you produce, the higher level of output you manage to manufacture, the lower your costs are going to be, because you spread the same number across larger and larger number of units. When your quantity goes up, the whole fraction, the whole ratio is always declining. What is important, though, is to remember that average fixed cost will try to reach 0, but will never be equal to 0. It's a line which goes close to horizontal axis but never touches it. It never crosses horizontal axis because it can never be equal to 0. Regardless of how many units you produce, you will still have to incur some positive expenditure. Total fixed cost, your numerator will always remain positive. So there will be some positive number here all the time, regardless of how many units you make and how close it is to 0. It will still be greater than 0. Okay, next question. Next question D. How much is total variable cost at output of 5? Total variable cost when output is 5. In order to calculate total variable cost, what we need to do, we'll need to take total cost and subtract total fixed cost. Variable costs are costs which directly vary with the level of output. And we know, because total cost is a sum of total fixed and total variable cost, to find this particular bit, we need to take total and subtract total fixed cost. So what is total cost of production for quantity equal to 5? Let's have a look at our table. When quantity equal to 5, our total expenditure which we incur is 210. Total cost, 210. This is what we've spent overall. Out of this, 55 was the fixed cost. So total cost is spread between total fixed cost and total variable cost. It's a sum of these two. And we know that total fixed cost is 55 pounds. The question is, what is total variable? It's whatever is left. It's 210 minus 55, which is 155 pounds. Right? If total is 210, total fixed is 55, then whatever is left, 155, is our total variable cost for this particular production level. Total variable cost will vary with the amount of output. We start at 0. when we don't produce any output at all, we don't incur any variable expenditure, no cost of materials, no cost of labor. That is why total variable cost will be 0. However, the more we produce, the higher this number will be. Total variable cost will go up. It's an upward sloping line. It can have different shapes. It can look like a line, like a straight line. It can look like a curve. It can be concave, convex. It depends on the technological process. It depends on how exactly you manufacture your output, whether you enjoy economy of scale or not. But generally, it's always upward sloping. The more you produce, the higher quantity, the higher total variable cost will be. And in our particular case, for level of output equal to 5, your total variable cost is going to be 155. Okay, next question asks you how much is average variable cost when output is 10. Average variable cost when output is 10. As before, to calculate any average, we take the total and divide by quantity. So we'll need to take total costs and divide by quantity. And we'll need to take total relevant total costs, specific number. We are asked about variable cost, average variable cost. That's why we take total variable cost and divide by quantity. We are asked how much variable cost we'll need to pay per each unit. So we take total number of this variable cost and divide by number of units. Number of units is 10. We are given this. So let's just have a look at total variable cost. What are variable cost for 10 units? We are not given this data in the table. We'll need to calculate this. However, we know that when output is 10, total cost will be 760. This is the only bit of information which we have, and we are going to use it. When output is 10, total cost is 760. Total cost is 760. And as before, we know that this consists of two parts, total fixed cost and total variable cost. Total variable cost is what we need, but we don't know this yet. However, we know total fixed cost. Total fixed cost is 55 pounds. It's always 55 pounds for our particular production process, which means that we can calculate total variable cost as the difference between 760 and 55. Overall, we spent 760. Out of this, 55 is fixed, which means that the rest, 705, will be variable cost. And now, because we know this, we can then plug it into our formula and calculate average variable cost per unit. If it cost us 705 to produce 10 units, it implies that it cost us 70 pounds, 0.5 to produce each and every unit. And this is our answer, 70.5 per each unit, average variable cost for this particular production level. Again, average variable cost will have a complex shape. It will have a U shape. There will be some point of minimum. We don't know where it is, but average variable cost. But we know that for our particular level of output, we will be producing with this particular amount. So we might be somewhere to the right of minimum, to the left of minimum, we don't know. But we will be producing somewhere at this particular level. These are our costs, average cost per unit, variable cost. Could be below minimum or above minimum, we don't know. Any questions at this stage? The last one. Okay, the last one. In the last one, we need to calculate average variable cost if output is equal to 10. Let me just create another page. We need to do average variable cost when output is equal to 10. To calculate any average cost, we'll need to take total cost and divide by quantity. Here we ask specifically about variable cost. That is why we'll need specifically total variable cost. So we'll take all variable cost and divide by all number of units which we produce. Right? This will give us average variable cost per unit. Total units is 10, total number of units is 10. So we'll need to figure out what variable cost is. Right? And to do this, we need to try and split all our expenditure between fixed and variable. We don't know what total variable cost will be. However, we know that when output is equal to 10, total cost is going to be equal to 760. This is what we've calculated. So have a look. Total cost is 760 pounds. And this consists of two components, total fixed and total variable cost. By definition, all our expenditure will consist of fixed and variable cost, right? We need to know this. This is what we need for our formula. This is what we don't know. However, we know the total cost is 760, and we also know that fixed cost is equal to 55 pounds. This is what we've identified at previous steps. And this is because if you look at this table, you will see that when output is 0, your total cost is 55. When output is 0, all of your costs are fixed costs. You don't incur any variable expenditure at all because there is no production yet. So all of these costs will represent fixed costs. This is how we can identify it. And because we know both total and total fixed cost, we can then figure out what variable cost will be. So total variable cost will represent the difference between 760 and 55. If total is 760 and one part is 55, then the rest, the second part, will be 760 minus 55, which is 705 pounds. This is what we spend on our variable cost, our materials, our staff, our electricity bills, etc. 705 pounds. We incur this expenditure in order to produce 10 units. We know that this is relevant for 10 units because we've taken this data from the table for 10 units. And if it costs us 705 to produce 10 units, it means that it will cost us per each unit 70.5 pounds, right? So we just we spread the whole amount which we've calculated across available number, relevant number of units. Okay? Yeah. Any other questions? No? Okay, let's move to exercise 2 then. Again, I will give you a few minutes to start working on this. I recommend that you work column by column. It will be so much quicker. I will give you a few minutes, and in the meantime, I'll copy-paste this information into my OneNote slide. Exercise 2. Please pay attention here. We have a production company which can employ a variable number of workers, and the wage rate is 10 pounds per worker per day, for example. So 10 pounds per worker. The cost of machinery is 50 pounds. And this doesn't change regardless of the level of staff you employ. You'll need to calculate all relevant costs. Again, think about this. Which cost will be fixed, which cost will be variable, and work column by column. It will be quicker. I will give you a few minutes. Right, question 2. So I've underlined the most important bits of information for us. Have a look. Output level depends on the number of staff employed. In other words, staff is the variable factor in the production process, which means that cost which we incur when paying staff, our wage bill, will represent a variable cost for the company. Could you please cover your nose with the mask? Yeah, keep it up, please. Thank you. So because output depends on number of workers, our cost, which we pay for hiring workers, will represent variable cost. And this cost is equal to 10 pounds per worker. This is how much we pay per each worker. So let's have a look. Pay attention. In this particular table, it's slightly more complex because our output will not increase by 1 unit as before. We will add 1 worker in the production process, but productivity of each worker will be different. For example, when we employ the first worker, he will be able to increase output from 0 to 5. In other words, his productivity will be 5 units. This is what he will manage to produce. When we hire the second worker, he will increase production from 5 to 15. So his additional product, which we will add, the value which we'll add to the company will be 10 units. He will generate 10 additional units of output. The third worker, which we will hire when we increase from 2 to 3 workers, will increase production level from 15 to 30. He will produce 15 units of output. So we will need to keep an eye on these changes in output, right? So please pay attention. You don't automatically increase output by 1 unit all the time. It can vary. So what are our total variable costs? It depends on number of workers. So when number of workers is 0, variable cost is 0. We don't hire anyone, we don't pay anyone. 0 pounds. When we employ the first worker, our variable cost will be equal to 10 pounds because it costs us 10 pounds per worker. When we hire 2 workers, it will cost us 20 pounds, 10 pounds each. 3 workers, 30 pounds. 4 workers, 40 pounds, and so on. This is how you complete the rest of the table. 40, 50, 60, 70, 80, 90, etc. 90 and 100. So our total variable cost will change with number of staff we employ. Does it make sense? Yes, and as before, we can sketch a little diagram here, which will show us the total variable cost go up. It's a straight line in this particular case. It starts at 0 and then goes up depending on number of output we produce. The more we hire, the more people we hire, the more we produce, the more we will have to pay. If we don't produce anything, total variable cost will be 0. This is what we can observe. It's a straight line in this particular scenario. Any questions? Okay, I'm changing the color now to green, and relevant information was underlined in green here in the task itself. Cost of machinery remains unchanged regardless of number of staff. In other words, our output level does not depend on the number of machines. We have certain amount of equipment and it remains unchanged throughout this production process. It remains the same. Right? We can produce different levels of output from 0 to 125 units with the same number of machines. Machines is our fixed unit, a fixed input, fixed capital, and it will cost us the same amount to have these machines. We pay the same amount, regardless of how many units we produce. How much does it cost us? 50 pounds. This is what we are given. This is our fixed cost. It's 50 pounds. It's unchanged. We pay 50 for 0 units, for 1 unit, for 5 units of output, for 15 units of output, for 30 units of output, regardless of number of staff, regardless of level of output, we will always pay 50 pounds. This is our cost of machinery. This is what we've paid to have these devices, appliances, this equipment in our factory. And the graph, as before, will represent a straight line at 50 pounds. Start at 50, and then it remains unchanged. This is our total fixed cost. Quantity and costs. All costs are measured in money, in monetary terms. Any questions? No? So this is 10 pounds per worker. Okay, next. How can we calculate total cost? I will use black here. Total cost is simply a sum of total variable and total fixed. It's all our expenditure which we incur in the production process. So if we pay 0 for variable cost for our materials and labor and 50 pounds for equipment, total cost will be 50. For 0 workers, for 0 units of output. When we produce at the next stage, 1 worker, 5 units of output, 10 pounds spent on raw materials and labor, 50 pounds on machinery, 10 plus 50, 60 pounds in total. Next, 20 pounds variable cost, 50 pounds fixed cost, 70 in total, and so on. And we continue with the rest. So strictly speaking, what you can notice here is that you take variable cost and add 50 pounds on top. So it will be the amount spent on variable cost plus 50 pounds. So strictly speaking, if you sketch a graph, it will look like that. It will repeat the same shape as your variable cost, but it will be higher by 50 pounds. It will start at 50 pounds. This is our fixed cost, 50 pounds. But same point, same curve, same blue curve, but goes up by 50 pounds. We shift it upwards by 50 pounds. We impose additional 50 pounds on top of the cost of materials. So it will be 100, 110, 120, 130, and so on, up to 150. Straight line as well. Repeats the shape of the variable cost. Just goes up. Shifts up by the amount of fixed cost. We impose additional 50 pounds on top of cost of labor and materials. Any questions? Okay. We need to calculate average variable cost. I'm using blue for variables, so I'm going to switch to blue color again. And as before, average variable cost can be calculated as total cost divided by quantity. Because we're talking about variable cost here, we take total variable cost and divide by quantity. This is the formula which we are going to use. So what is variable cost when output is 0? It's 0. So strictly speaking, to calculate this, we take 0, divide by 0, which cannot be calculated. So there will be no answer here. 0 divided by 0 can't be calculated from the mathematical point of view. Next, average variable cost when output is 5. We've spent 10 pounds, total variable cost is 10, in order to produce 5 units of output. Right? 10 divided by 5 is going to be equal to 2. Next, we've spent 20 pounds variable cost to produce 15 units. Pay attention, we don't divide by number of workers, we divide by level of output. We calculate cost per unit of output, not cost per worker. Right? So 20 pounds spent to produce 15 units, 20 divided by 15, is equal to 133. Next, 30 pounds spent to produce 30 units. 30 divided by 30 is equal to 1. Next, 40 pounds spent, managed to produce 50 units. 40 divided by 50, 0.8. Next, spent 50 pounds, produced 75 units. 50 divided by 75 is equal to 0.67. I'm rounding up slightly. Next, 60 pounds spent, produced 95 units. 60 pounds, 95 units. These two variables, these two values, it's going to be equal to 0.63. Next, 70 pounds spent, produced 110 units. 70 divided by 110 is equal to 0.64. And so on. 80 pounds divided by 120, 0.67. Next, 90 pounds divided by 125 units is equal to 0.72. Then 100 pounds spent to produce 125 units, 0.80. So these are our numbers. Please pay attention. This particular case, this particular example illustrates the law of diminishing returns. Let me just remind you what this is. Law of diminishing returns. This was part of the lecture. The definition might be not very straightforward, but the whole idea is actually quite simple. The law of diminishing returns states that as you add more and more variable factor into the production process, the additional output produced by each variable unit, variable input will drop. Each unit of variable input will add less and less additional output to the production process. As I said, it might sound complex, but in fact, it's very simple. Let me just draw it for you and you will understand. For this, we are going to look at these first two columns, number of workers and number of units produced. So what we'll do, we'll plot number of workers here along horizontal axis, workers, and output here along vertical axis. And this is probably the only graph where output will be located along vertical axis. Have a look. 0 workers, 0 output. We start at 0. 1 worker produced 5 units of output. 1 worker, 5 units. Second, third, fourth, fifth, sixth, seventh, eighth, 9, and 10 workers. These are our workers. Let's have a look how will they increase our production process. I'll start with lower number probably. This will be our first point. Second worker produces 15 units. So somewhere here, 15 units. In other words, second worker adds 10 units to the production process. It increases output by 10 units. It's a difference between 5 and 15. Third worker. Together, 3 workers produce 30 units of output. We are somewhere here. The third worker will increase production from 15 to 30 units. In other words, he will add 15 units. He will help us to increase production by 15 units. Next point. Worker number 4 produced 50 units. And this is where we start to increase gradually, we observe our law of diminishing returns. Have a look. When we've added the 4th worker, our output increased by 20, but this will, we can see that in each additional worker helps us to specialize, and we are able to become much more efficient. We increase production, our output increases exponentially, something like that. But it will not always be the case. It's not always profitable to hire more and more workers. For example, let me see. So basically, 5th worker produces 75. This is the last bit where we enjoy this exponential increase, 75, increased by 25 units. Our next point. And after 5 workers, it stops. Worker number 6 generates 95 units, which will be less than before. 95 units. 6 workers produce 95 units. In other words, our increase in production is 20 units only. This was our maximum. But beyond this point, beyond 5 workers, each additional worker will generate less and less. So worker number 6 produced 20 units only. Worker number 7 increases production to 110. In other words, we see an increase by 15 units only. Not 25, not 20, 15 only. Worker number 8 produces 120, so an increase by 10, and so on. And eventually, when we add the last, the 10th worker, it doesn't increase production at all. And if we draw the graph, it will look something like that. There will be a point, like inflection point, where beyond which point each additional worker will generate less and less additional output. So this is an idea of the law of diminishing returns. Beyond fifth worker, the rest will contribute less and less and less, and eventually we'll reach a point where there is no point hiring more workers. They don't add anything. We incur additional expenditure. We pay them their wages, but they don't produce anything. So we would be better off staying with 7 or 8 workers. There is no point hiring worker number 9 and 10. They cost us more than they generate. They're not worthwhile. So this is an idea of the law of diminishing returns, which this particular table illustrates. So this was like a sideline. Now let's go back. So we've calculated average variable cost, and we can sketch the graph. How can we do this? Let's look at the numbers, how numbers change when output increases. We have output along horizontal axis. Let's have a look how average variable cost will change. We start at 2, then it drops 1.33, 1, 0.8, 0.67, 0.63. In other words, as output increases, average variable costs go down. Then we've reached some point of minimum, and beyond this production level, average variable cost will start to go up again. 0.64, 67, 72, 0.8, and so on. So there will be some point of minimum of average variable cost. Point of minimum goes down, reaches minimum, then goes up again. You can see this from the numbers. They drop, they decline, reach some minimum, and then start to increase. Any questions at this stage? Okay, next, average fixed cost. This is what we need to calculate. And as before, to calculate any average number, we take total cost and divide by quantity. And because in this case, we need to calculate average fixed cost, we of course divide total fixed cost by quantity. We take total fixed cost and spread it across relevant number of units. Our total fixed cost is always 50 pounds, so it will be very simple. We take 50 and divide by relevant number of units. So 50 divided by 0, 0 units, 50 divided by 5 units, units of output, 50 divided by 15, units of output, 50 divided by 30, by 50, by 75, etc. So you just divide 50 by relevant number of units, 50 by 95, and so on. And if you do this, you will get these numbers. 50 divided by 0 cannot be calculated, so we skip this. 50 divided by 5 is 10. 50 divided by 15, 3.33. 50 divided by 30 is 1.67. 50 by 50 is 1. 50 by 75 is 0.67. 50 divided by 95 is 0.53, and so on. I will just write down the solutions here, the answers, because otherwise we don't have enough space to write down everything. 0.4 and 0.4, something like that. Average fixed cost. So what you can notice here is that average fixed cost is always declining. We start at 10, then it drops to 3, 1, 6, 1, 0.6, 0.5, 0.45, 0.42, 0.4. It's always declining. Average fixed cost looks like this. It always goes down. The more we produce, the cheaper it becomes per unit. Simply because we spread the same amount across more and more units. So per unit, it will become cheaper and cheaper and cheaper. In the exam, you will need to be able to identify shapes of the cost curves by looking at the graph. So you need to know features of each cost curve. Which curve starts at 0, which is upward sloping, which is downward sloping. There will be some questions based on these shapes, so you need to be comfortable with them. And in your accountancy courses, you will also have to work with the cost curves quite a lot. It's one of the major tasks for accountant to be able to identify different costs, to give advice on how to minimize them, to work out break-even point, and so on. And we'll cover this in this module as well. So you need to be very comfortable with costs. And in accountancy courses, you will deal with the same cost. They will be just called differently. In accountancy, variable cost will be called direct cost, direct expenditure, and fixed cost will be called overheads. but the idea is absolutely the same. Overhead is what you pay apart from the production process itself. Okay, now average cost. Next column, average cost. As before, to calculate average, we take total cost and divide by quantity. And because we're trying to calculate complete all average cost per unit, we take all total cost, our total expenditure, and divide by quantity. So we take this black column, total cost, and divide, so column number 1, 2, 3, 4, 5, column number 5, and divide this by column number 2. Total cost divided by output. So it will be 50 divided by 0, can't be calculated. Next, 60 divided by 5, 60 pounds, spent to produce 5 units, 12. Next, spent 70 pounds to produce 15 units, 70 divided by 15 is equal to 467, 467. Next, spent 80 pounds to produce 30 units, 80 divided by 30, slightly increase this, 80 divided by 30 is 267. Next, 90 pounds spent to produce 50 units, 90 divided by 50 is 1.8. 100 pounds, 75 units, 100 pounds divided by 75, which is 133. Next, 110 divided by 95 units. Black column divided by black column, 110 divided by 95, 116. Next, 120 divided by 110, which is 109, and so on. 130 pounds spent to produce 120 units, which is 1.08, and so on. 140 by 125, which is 1.12, and final one, 150 divided by 100, which is 1.2. What you can also do, have a look. We can use different formula. We've calculated total cost as a sum of total variable and total fixed cost. So column number 3 plus column number 4 gave us column number 5. We can do the same with the average cost. Average cost can also be calculated by adding up average variable and average fixed cost. Together, these numbers will give us average cost. To give you an illustration, have a look. 2 plus 10, 2 plus 10 gave us 12 per unit. So it's fixed cost per unit 10 plus variable cost per unit 2 gave us 12. I'm using simple numbers which are easy to trace. Average variable cost 0.8, average fixed cost is 1, all average cost 1.8. So together we add up this blue column plus green, and this will give us the black column. Or at the bottom, numbers are simple to trace. 0.8 variable cost, 0.4 fixed cost. Together, this will give us 1.2. So you can use this technique instead, depending on whichever is easier for you. Okay? And final bit. Final is probably slightly more complicated. For some reason, students struggle with marginal cost quite frequently, but there is no reason to be afraid of them. So marginal cost. Marginal cost, remember, these are always additional costs of one extra unit. It shows how total cost will change when output changes by 1 unit. We take change in total cost and divide by change in output. In economics, it's one of the features of economic way of thinking on the margin. If you've attended the first seminar, 10 Principles of Economics, one of the rules which I've mentioned, which I've discussed with the class was we think on the margin. All decisions are made on the margin. And I mentioned that we are going to come back to this later. All economists compare marginal benefits and marginal costs of any decision we make. Any economic decision depends on what will overweight, marginal costs or marginal benefits. All decisions are made on the margin. In order to decide, should we do a certain thing or not, should we invest in a particular project or not, should we start producing a particular output or not, we'll need to compare marginal benefits and marginal costs, additional costs and additional benefits of this particular decision. If we do that, Will we incur more costs or will we get more benefits from this decision? If benefits, additional benefits outweigh costs, we should proceed. We should invest. We should start production. We should go for it. If, however, additional costs of this are higher than additional benefits, it's not worthwhile doing. So we're always comparing additional costs of this decision. For example, you go to McDonald's, you are very hungry, and you probably want to have quite a few hamburgers. You order a few hamburgers. How many? It depends on what additional benefit you will get compared to the cost. For example, your first hamburger will definitely, when you're hungry, generate a lot of benefit for you. You are so hungry, you will enjoy it a lot and you will buy it. Probably the second hamburger will again generate, if you're truly hungry, you will want to go for the second hamburger. You will have it a second portion and you will enjoy it as well. The benefit is greater than costs. If, however, you've had 10 hamburgers, buying 11s will probably make you more harm than good, and basically it's not worthwhile. It's not about money, it's comparison between additional benefit and additional cost. It's just not worthwhile buying it because you will not enjoy it that much. You might feel even bad after eating it. So this is a very simple illustration. Or when you come to the lecture, you have an option to sleep for 2 extra hours or go to the lecture. You'll need to compare costs and benefits. What you will get from coming to the lecture and what you will lose. You will lose 2 hours of sleep. So these are your costs. This is what you will need to pay for coming to the lecture, what you will get from it. If lecture is going to be very useful, if you will learn lots of important material, it will help you to prepare for your exam, then obviously benefits are greater than costs and you will need to go for it. So you might understand that I don't want to do it. It's costly for me. I don't want to wake up. I don't want to get out of my bed, but the benefits outweigh my discomfort, my suffering, so I will go for it. So this is how economists make decisions. So that's why marginal values are very important in economics. That's why we always try to calculate marginal benefit, marginal revenue, marginal cost, and analyze them. So marginal, let's have a look how we can calculate marginal cost here. Marginal cost show how total cost increase when total output goes up. We cannot calculate it here for the very first value because we need to change, we'll need to divide by change in quantity, and quantity didn't change yet. We haven't even started production level. We simply don't have data for change in quantity. So we'll start from the second point. Second number here. Our output increased from 0 to 5. So change in output will be 5. And total cost increased from 50 to 60. This is what we are going to analyze. I'm color coding again to make it easier for you to follow me. Total cost went up from 50 to 60. This is change in total cost. This is our numerator. Cost went up from 50 to 60. Additional expenditure is 10. And we need to divide this by change in output. Output increased from 0 to 5. Change in output is 5. So 10 extra pounds spent in order to produce 5 extra units, which means that it cost us 2 pounds per unit. So the cost of this unit, this additional increase in the production level, is 2 pounds. If we want to jump from this production level to this production level, it will cost us 2 pounds per each unit. Next, when we hire an additional worker, it allows us to increase output from 5 to 15, and our costs will go up from 60 to 70. What are the marginal costs of this additional increase in the production level? It's rather discrete. We increase our production step by step as we hire more workers. So we will have a look how much it will cost us. So total costs go up from 60 to 70. In other words, change in total cost is 10. They go up by 10. What is change in output? 10 as well. It increases from 5 to 15. So the difference is 15 minus 5, which is 10 units. That's why marginal cost is 10 divided by 10 is 1. Have a look. Change in total cost will always be equal to new cost at the new production level minus old cost. And what we can see is that our total cost will always increase by 10 pounds in this particular production process. 110, 120, 130, 140, etc. So our numerator will always be equal to 10. 10, 10, 10, 10. In this particular scenario, it will not always be the case, but in our situation, our total cost always go up by 10 pounds. So numerator will always be equal to 10. So we'll only need to trace our denominator, change in output levels. So for this point here, for number of workers equal to 3, output goes up from 15 to 30. It's a change between 30 and 15, which is 15. So 10 divided by 15 is equal to 0.67. As we jump from 3 to 4, output increases from 30 to 50. Difference is 50 minus 30, 20 units. So it's 10 divided by 20 units. The result will be 0.5. So we always divide 10 by some number. 10 divided by some number, change in quantity. So let's just plug this in. Here, output jumps from 50 to 75. 75 minus 50, difference is 25. 10 divided by 25, 0.4. Next, 75 to 95, difference is 20. 95 minus 75, difference is 20. 10 divided by 20, 0.5. Next, 95 to 110. 110 minus 95, difference is 15. 10 divided by 15 is equal to 0.67, 2/3. Next, 110 jump to 120 units, difference is 10. Output increases by 10 units. 10 divided by 10 is 1. Next, 120 up to 125, 5. 10 divided by 5 is 2. And here it's 0 actually. So strictly speaking, we can't calculate this, so I can cross it out. There is no increase. Yeah, output remains unchanged, so we cannot calculate, we cannot divide by 0. So let's have a look again at the shape of this, curve, if we sketch this, and we can use our data to do this. So quantity and marginal cost. We can see that it also has a minimum. So initially we started 2, go down, 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 up to 0.4. That's the minimum, and then it goes up again. Beyond certain point, it goes up. So our marginal cost curve will look like this. Goes down, originally reaches some point of minimum, and then goes up. Has a U shape as well. So this is what you can, what information you can identify from this particular table. Again, it gives you quite a lot of information, quite a lot of data. And now we'll need to answer the questions. Is this clear? Are the calculations clear? Are you certain how to do this? Yes, if you are stuck at a certain level, or when you will revise, if you don't understand how something was done, you can always download this presentation and have a look at my explanation, listen to them again. Okay, let's answer our questions. There were several questions underneath the table. Let's have a look at this. What time period do these data cover? Short or long run? Any ideas? Questions? Any thoughts on this? It's a short run. All production, strictly speaking, takes place in the short run. Why is that? Because you are stuck with a certain amount of machinery. We are told here that the cost of machinery remains unchanged. We are stuck with a certain amount of equipment, and by definition, short run is a period of time when we have at least one fixed factor of production. Long run is a period of time when all factors are variable, when we are able to adjust both number of workers and amount of machinery. Here, we are stuck with certain amount of machines, which means that we are operating in the short run. And all production always operates in the short run. Long run simply is the movement between different short runs. In the long run, we are able to vary our capital. We can decide that 5 machines is better for us than 4, or is better than 3, or is better than 10. But after we've made the decision that it is optimal for us to have 5 machines, we've chosen this, we've installed this machine, and that's it. And then we start production with these machines, and it becomes a short run for us again. So long run is, strictly speaking, a movement between short runs. Yeah. So all production takes place in the short run. So here we are talking about the short run because we have fixed cost. And since some costs are fixed, it means that we are fixing some inputs are fixed. So the answer to question A will be short run. So question 8, let me write this down. Short run, since machinery is fixed. We have fixed cost. Fixed input. Okay, next. At which level of output firm's cost per unit is minimized? B. Firm's cost per unit minimized. In other words, we are asked to find out which level of output will generate minimum cost per unit, minimum average cost. We will need to figure out what quantity level will result in lowest possible cost of production. And to answer this question, we'll need to look at our table. What I will do, I will open nicely written answers. So these are our data. We need to analyze this particular column. This particular column. So this is what we've calculated. We'll need to find minimum costs. And as you can see here, the minimum cost will be 108. So this is the level of production at 8 workers when output is equal to 120. When we produce 120 units, our average cost per unit given by this column is minimized. It's the lowest possible cost which we can achieve. So lowest cost is 108, and this takes place when output is 120. So that's why this is the level of output which allows us to minimize cost per unit. This is the level of output which allows us to produce in the most efficient manner. This is the most efficient production level we can produce with the lowest possible cost. However, what is important is that it doesn't necessarily imply that you should operate at this level of output. It doesn't necessarily tell you that you need to hire 8 workers and produce this level of output, because it does not necessarily imply that you will earn the highest possible profit. This is what we are going to study at the next lecture. Profit maximization is not the same as cost minimization. Lower cost of production definitely helps to increase your profit, but it doesn't guarantee that your profit will be maximized. Profit is the difference between revenue and costs. This is what we'll cover later. And there will be different shapes to the revenue curves and the cost curves. What we'll need to figure out is the production level which allows us to maximize this gap between profit or between revenue and costs. And this will not necessarily take place at the point where costs are minimized, costs per unit are minimized. It helps, it's better to produce with lower cost rather than higher cost, but it does not necessarily guarantee that your profit will be maximized. So strictly speaking, you will need, as a company, as a business, you will need to select your production level depending on your priorities, depending on your objectives. What are you trying to achieve as a business? Are you trying to earn money? You try to maximize profit? Or are you just starting up? Maybe you're trying to capture biggest possible market share. You need to attract customers. And in this case, if you're trying to compete on cost, maybe trying to operate with lower profit but lower prices in order to have to start in this market, in order to attract some customers, to create the loyal customer base. Maybe for you it will be better to sacrifice some profit for the sake of lowering prices, producing very cost effectively, and capturing market share for the future. You will be able to milk this market later on, right? So the firm will make decisions based on their objectives. Cost minimization is one objective, profit maximization is a different objective. So in this particular case, if you want to minimize costs, you will need to operate at 120 units of output with 8 workers. Any questions? No? Okay, next question asks you, what is the average cost per unit when no output is produced? When no output is produced, we cannot calculate average cost per unit here, simply because cost per unit is total cost divided by quantity. There is no quantity, right? So we cannot calculate it, strictly speaking. However, we know that we are paying fixed cost. We know what fixed cost will be, cost of machinery, 50 pounds. So total cost can be calculated, but not cost per unit when no units are produced. From the mathematical point of view, the first unit will cost you 50 pounds per unit. When you produce 2 units, it will cost you 25 because you spread 50 between 2 units. When you produce 10 units, it will cost you 5 pounds per unit, and so on. Any questions? Okay, next question is very simple. You are asked to plot curves, total cost, total variable, and total fixed. And this is a very simple task. So you just follow the scale and your graphs will look like that. So very simple. I'm pretty sure that all of you will cope. You just plot point by point. curve by curve. So what is important here is that, as you can see here, this is exactly the shapes which we've demonstrated. Total variable cost starts at 0 and then goes up. It's always upward sloping and always starting at 0. And if we come back to our sketch here, total variable cost. This is the little blue graph which I've sketched here. Have a look. This is the one. Starts at 0, then goes up. And as I said, it can look differently. It can look like a straight line. It can be a curve, concave, convex. So in this particular scenario, it's a curve which has this particular shape, right? Black line starts at 0, then goes upwards. The more you produce, the more you spend. If you don't produce, you don't spend anything on variable expenditure. Total fixed cost is a straight line which starts at 50. Total fixed cost is always the same amount. It's always the same number. That's why they are called fixed. Start at 50 and then remain unchanged for our production level, right? As long as we have the same amount of machinery, our total costs remain 50. If we want to double our machinery, total fixed cost line will shift upwards. It will shift to 100, then to 150, and so on. But again, after we've chosen the amount of machinery which we are going to use, it will remain unchanged, regardless of level of output. Okay, right? And the next curve is total cost curve, shown by red line. As you can see here, it's simply a sum of the black curves. What we are doing here, we take total variable cost curve and shift it upwards by 50 pounds. What we can notice here is that this distance always remains 50 pounds. If we take this distance, for example, it's 90 minus 40, it's 50 pounds. Distance between these points, for example, it's 110 minus 60, it's 50 pounds. Difference between these points, these top points, is going to be 150 minus 100, 50 pounds. So the distance between these two curves is always 50 pounds. We take black line, total variable cost line, and shift it up by 50 pounds. We impose additional 50 pounds on top of the variable cost. That's why the red line will repeat the shape, total cost curve will repeat the shape of the variable cost of materials, plus fixed cost added on top. Okay? So hopefully this graph will help you to memorize the shape of the cost curves. What you will also need to remember are the shapes of other cost curves: average cost, average variable cost, average fixed cost, and marginal cost. These are separate cost curves. All of them will have a U shape, apart from average fixed, which is always downward sloping. The only cost curve which is always downward sloping. This is what you'll need to memorize. I've uploaded video lectures explaining this, and I've split all of my video lectures into little chunks, into little segments, video clips. They last between 5 and 20 minutes. This will help you to identify which particular section you need to revise, so you will not need to go through whole 2 hours of lectures to find information which you need. You can just open the clip which you need and work through this particular information. It's all available on Moodle, so hopefully you will be able to work through this. Please make sure that you cover this and pay attention to the relationship between different curves, average variable and marginal cost, how exactly they look like they're located relative to each other, because they are not just random set of graphs. Strictly speaking, if you sketch a graph, it will look like that. If you start with average variable cost, then average total cost, then average fixed cost, it will look like this, and marginal cost line will look like this. These are not just random lines. There is an important relationship between them, and there is important explanation of why they look like that. What is the distance between these points? Why these 2 points, average cost and average variable cost, are convergent to each other? Why marginal cost passes through points of minimum of average variable cost and minimum of average cost. There is important economic explanation to all this, and this was covered in the lecture. Please make sure that you go through this, because there are questions on this in the exam. And in fact, there is an important meaning to all these points. So this is, let's call these points X, Y, and Z. Again, I've mentioned this in the lecture. Point Z is the level of output. It shows the level of output where the law of diminishing returns kick in. If we produce some level of output below this level Q1, for example, it means that we benefit from scale economy, from specialization. Each additional unit which we produce allows us to reduce the cost. We produce it in a very efficient manner. However, beyond this point, the more we produce, the more expensive it becomes. Marginal costs start to accelerate. So costs and quantity. This is an important meaning for point X. Point Y has a meaning too. It's a shutdown point. It tells us that if the price drops below this level, let's call it price PY, if price drops below this level, we need to shut down production immediately to minimize our losses. And point Z shows break-even quantity and price. Let's call this QZ. Break-even quantity. This is a break-even point, which is a very important point, very important concept for an accountant, because you need to be able to produce at least this amount of output in order to break even, in order to remain profitable. If you want to make a profit, you will need to produce more than this. Otherwise, you are not just covering your expenditure. So there is an important interpretation, important economic meaning to all these points, and we will continue going through this in next lectures, but please make sure that you learn the links between all of these curves, what was covered before next topic. Okay, I think that's all I wanted to cover. Let me just plug in my computer because it's running out of power. That's all I wanted to cover with you. I went through the most difficult questions. There are a few questions left here. True or false, some true or false questions, and some multiple choice questions. Please make sure that you finish these exercises yourself and check your solutions again against what's available on Moodle. Okay? Right? This is not difficult, but this is your extra practice. This is the type of questions which you will get in exam, so it makes sense to practice. And this week, we are starting profit maximization. We'll add total revenue, what we've learned from demand, how revenue changes due to changes in elasticity along the demand curve. We'll combine together demand side and our production side, and we'll start learning profit maximization ideas.